This will be the last day that we talk about absolute value equations. We're finding the solution set. In other words, what values of x make this statement true? So let's take a look at problem number 1. 3 times the absolute value of 5x plus 2 minus 4 is equal to 50. So what do? We need to do algebra before we solve for x. So what we need to do is get the bars isolated. So again, you don't have to do it this way. I personally like to show that I'm getting the highlighted part isolated before I break it up into two equations if necessary. So I've got 3 times yellow minus 4 is equal to 50. So I'm trying to isolate the bars. So how do I isolate the yellow part if it's 3 yellow minus 4? Right? I'm going to add 4 on both sides. And now the negative 4 and the positive 4 cancel each other out, leaving me with 3 times the absolute value of 5x plus 2 is equal to 54. Are the bars isolated yet? No, because I have 3 times the bars. And now I need to isolate the bars. 3 times bars is equal to 54. How do I isolate if it's 3 times the absolute value? I'm going to divide both sides by 3. So I'm just going to rewrite the problem. Let me just show that I've got, again, you don't have to do the highlighter part, that's just my notation. So I'm going to divide both sides of the equation by 3. Now I've got the absolute value of 5x plus 2 is equal to, 54 divided by 3. If 60 divided by 3 is 20, 19 times 3 would be 57, that'd be 18. So now I've got the absolute value of 5x plus 2 is equal to 18. Are the bars isolated? Yes. And is this problem solvable? Yes. Now I'm going to take the inner part of the absolute value bars and split it into 2 cases. Remember, we have to account for both kinds of distance, forwards and backwards. So the inside of the equation, 5x plus 2 is equal to 18, or 5x plus 2 is equal to negative 18. Okay, so now let's just say I start with the right side since I'm a positive person. 5x plus 2 is equal to 18. Now I'm going to undo the layers of x by undoing that plus 2 layer first. So I've got 5x plus 2 is equal to 18. I'm going to subtract 2 from both sides. So that would make this 5x is equal to 18 minus 2 is 16. So now I've got 5x is equal to 16. If I divide both sides of the equation by 5, that leaves me with x is equal to 16 divided by 5, which is 5 goes into 16 3 times with 1/5 remaining. So that's 3.2. Or if you want to leave this as 16 over 5, be my guest. That's totally up to you. Okay, 5x plus 2 is equal to negative 18. Same thing. I'm going to undo the outer layer by subtracting 2 from both sides. And now I've got 5x, negative 18 minus 2 is equal to negative 20. And now I've got to solve 5x is equal to negative 20. How do I undo that layer? I'm going to divide both sides of the equation by 5, leaving me with negative 20 divided by 5. Negative 20 divided by 5 is negative 4. You plug them back into the original equation, and you will still get the output of 50. You can check it yourself. Okay. Problem number 2. Negative 2 times the absolute value of 12x minus 60 is equal to negative 600. So I see a negative as an output. Can I make that judgment right away that this problem has no solution? No. What do I need to do before I make that judgment call? I need to get the bars isolated. I cannot make that judgment call until I get the bars isolated. So until then, I'm going to call this problem negative 2 times the bars. And how do I get rid of that negative 2 if it's multiplying to the absolute value? I'm going to divide both sides of the equation by negative 2. So now I've got the absolute value of 12x minus 60 is equal to negative 600 divided by negative 2. Negative 600 divided by negative 2 is positive 300. Now, are the bars isolated? Yes. And is the problem solvable? Yes. Even though the problem started with a negative output, well, that's just because we had a negative number multiplying the absolute value bars. That's why the output was negative. Now that the bars are isolated, we can tell that the bars equal a positive number. So therefore, we can kind of split this into 2 equations. One to account for forwards, one to account for backwards. So either 12x minus 60 is equal to positive 300, or 12x minus 60 is equal to negative 300. Okay. Let me just rewrite this so I'm a little bit ahead. Okay. So let's take a look at the right side. If I have 12x minus 60 is equal to 300, in what order do I undo the layers of x? I'm going to undo the outer layer by adding 60 to both sides. So that would make me 12x is equal to 360. Okay, and now how do I get x isolated? I'm going to divide both sides of the equation by 12. So now x is equal to 360 divided by 12. Well, if 12 goes into 36 3 times, then 12 times 30 must be 360. So that's one of the solutions. Let's figure out the other side now. Well, I'm going to repeat by undoing the layers of x, but this time the output is negative 300. So I'm going to do negative 60 plus 60. That cancels out. And then I've got 12x is equal to, well, 60 minus 300. That would be negative 240. And now I'm going to divide both sides of the equation by 12. 12 divided by 12 becomes 1, so that cancels out to become 1x. A negative divided by a positive is a negative, so I'm going to focus on 240 divided by 12. Well, if 24 divided by 12 is 2, then 240 divided by 12 needs to be 20. So x is equal to negative 20 if it's 12x minus 60 is equal to negative 300. We can plug in both values of x and get the correct output, negative 600, in the top part of the equation. Okay. All right, on to problem number 3 now. The absolute value of 14x minus 3 plus 47 is equal to 5. What do I do to get the bars isolated? I'm going to subtract that 47 from both sides. Remember that until these highlighted bars are isolated, I can't do anything. So in other words, think about this like Highlighter plus 47 is equal to 5. Yellow plus 47 is equal to 5. Well, if I need to get the bars isolated, I'm going to get the highlighted part isolated by subtracting 47 from both sides. So that cancels out. And now 5 minus 47 is negative 42. Are the bars isolated? Yes. Is this problem solvable? No. The bars equal a negative number, and we all know that there's no such thing as negative distance. There's nothing I can plug into these absolute value bars that will get me an output of negative 42. Remember, negative 42 can go inside the bars, but it'll always spit out positive 42. This is impossible. X has no solution because the absolute value bars cannot generate a negative output. Okay. Number 4. Negative 5 times the absolute value of x plus 10 is equal to 60. Are the bars isolated? They're not. So I'm going to put a highlighter on there just to keep an eye on it. I got my eye on you, absolute value. So if this was absolute value of, if this was negative 5 times yellow, how do I get yellow isolated? I'm going to divide both sides of the equation by negative 5. So now I've got absolute value of x plus 10 is equal to negative 12. Are the bars isolated? Yes. Is this problem solvable? No. In other words, the absolute value bars are isolated, but I don't care what you are. You will never put something in the absolute value bars and get negative 12 as the output. There's no such thing as negative distance, so x has no solution in this problem. This problem is impossible to solve. Okay. 2 more problems, and then we'll call it a day, and good luck on that test. So now, the absolute value of 4 minus 7x plus 10 is equal to 27. Are the bars isolated? No. But is this problem solvable? Wait, we haven't done that yet. So the bars are not isolated. So we need to establish how do we get the bars isolated. If this is yellow plus 10 is equal to 17, how do I get yellow isolated? I'm going to subtract 10 from both sides. Now I've got the absolute value of 4 minus 7x is equal to 27 minus 10, that will be positive 17. Is this problem solvable? Yes. Since the bars are isolated and it equals a positive output, I'm going to split this into 2 equations and solve for x on both. I'm going to get a better pen since this one's running out of ink. So I've got 4 minus 7x is equal to 17, or 4 minus 7x is equal to negative 17. I have to account for forwards and I have to account for backwards for the absolute value on the inside. So this one makes me a little bit nervous because I've got 4 minus 7x. So a lot of people would be tempted to add 7 on both sides because it's on the right part of the left side of the equation. Yes, try saying that 5 times fast. But you can always rephrase the problem to make it easier on you. So I would rephrase this problem as negative 7x plus 4 is equal to 17. Notice that I kept the signs. This is a positive 4. This is a negative 7x, and I just flip it around, but keep the signs. Do not write this problem as 7x minus 4. That would be incorrect. So now that I've got negative 7x plus 4 is equal to 17, what's my next move? I'm going to subtract 4 from both sides. So why don't I do that? So if I subtract 4 from both sides, I get negative 7x is equal to 17 minus 4, which is 13. And then I've got negative 7x is equal to 13. So I'm going to divide both sides of the equation by negative 7. Now, if you plug that into the calculator, you're going to get a weird decimal. If it doesn't end, then I would leave it as a fraction. Honestly, that's just my personal opinion. Please do not round. Rounding does not get you the exact solution. So if you want the exact solution, when in doubt, just leave it as an improper fraction. I'm not gonna penalize you for leaving this as negative 13/7. So that's one of the solutions. Okay, but we have to account for the other side. Once again, if you cannot see this as a subtract from 4 from both sides in the first step, that's okay. I would rephrase this problem as negative 7x, right, at the front, and then that has no sign, so it's automatically positive 4 is equal to negative 17. Now, if it was up to you, how would you undo the layers to solve for x? Subtract 4 from both sides. So I've got negative 7x plus 4 is equal to negative 17. So if I subtract 4 from both sides, that cancels out. And now I've got negative 7x is equal to, what's negative 17 minus 4? That'd be negative 21. And now how would I get x isolated? I'm going to divide both sides by negative 7. And now x is equal to negative 21 divided by negative 7. Negative divided by negative is a positive. 21 divided by 7 is positive 3. So either x is equal to 3 or x is equal to negative 13/7. Either way, you get a correct, you get the same output in the solution set. Okay, last problem. Okay, so now, this one's a headache. Negative 3 times the absolute value of 1 minus 5x plus 12 is equal to negative 48. Is this problem just, can I just make that judgment call that it's no solution? For the final time, get the bars isolated before you make that judgment call. So for now, I'm going to call this problem algebra before algebra. I've got negative 3 yellow plus 12 is equal to negative 48. So if I want to get yellow isolated, I'm going to need to treat this like an algebra problem before I do my algebra problem. I'm going to subtract 12 from both sides. So now I've got negative 3 times the absolute value of 1 minus 5x. Negative 48 negative 48 minus 12 is negative 60. Is this problem, are the bars isolated now? No, I've still got the bars multiplied by negative 3. So now, negative 3 times the absolute value of 1 minus 5x is equal to negative 60. So I'm going to divide both sides of the equation by negative 3. So now that I've got the absolute value of 1 minus 5x, negative 60 divided by negative 3, that is positive 20 actually. Even though the problem started with a negative output, but that's just because I had that negative 3 times layer on it and then I added 12. So yeah, no wonder that this whole thing was negative, because the absolute value has to be either positive or 0. So now what do? I'm going to split this up into two cases. Either 1 minus 5x is equal to negative 20, or 1 minus 5x is equal to positive 20. So I'm going to count for both cases. This makes me nervous because it's 1 minus 5x instead of 5x minus 1. How do I rephrase this so that my anxiety calms down a little bit? Once again, you don't have to do this, but if it makes your life easier, remember that the 1 is positive, and the negative 5x is obviously negative. So I'm going to keep the signs the same and make this problem negative 5x plus 1 is equal to 20. Sorry, I had to get a sip of water. I was getting parched. So now I've got negative 5x plus 1 is equal to 20. So now I'm going to do some algebra. Business as usual. I'm going to subtract 1 from both sides. And that gets me negative 5x is equal to 20 minus 1, which is positive 19. And now I want to solve for x. Negative 5x is equal to 19 by dividing both sides of the equation by negative 5. Now, if I do 19 divided by negative 5, I'm going to get a decimal. So you can write this problem as negative 19 over 5. That's no problem. As long as it's a simplified fraction, I'm okay with that. But if you're like me and if the decimal ends, you like to write down, that's cool too. So negative 5 goes into 19 3 times. That's negative 3. And that's 4/5 remaining. So it's negative 3.8. Okay. The other side, once again, 1 minus 5x makes me nervous if I'm solving for x. So I kind of like to rewrite it like this. Negative 5x plus 1 is equal to negative 20. And now I'm going to subtract 1 from both sides. So now I've got negative 5x is equal to negative 20 minus 1, which is negative 21. And now I'm going to divide both sides of the equation by negative 5. So then x is equal to, okay, negative divided by negative is a positive. 21 divided by 5 is a decimal because 5 goes into 20 a whole number of times. And there's 1 out of 5 remaining. So that would be positive 4.2. So your solution set is, in this problem, either x is positive 4.2 or negative 3.8. And if you plug those in for x, you will get a solution that both solutions get you an output of negative 48. All right, good luck. The test is due Friday at 11:59 p.m. Good luck.